Hello, one. So we have number 22 from AMC 12P. So we have a parallelogram has area of 1,000,000 and the vertex A at origin, and all other vertices are in the first quadrant. And vertices B and D are lattice points on the y equals on the lines y equals x and y equals kx, and then k is bigger than 1, respectively. How many such parallelogram exist? So let's start with kind of visualizing what's going on. So we have a coordinate like system. So let's say we have this is origin, which is A, and we have y equals x, which has to go through right in between x and y axis. And the second line, y equals kx, k is larger than 1, so this has a slope of 1, so which means k equals k, like y equals kx would be something like that. So let's say this is y equals x, and then y equals kx. Okay, so the b is on the y equals x, so let's say this is b, and there is like d on this one. And so AB, and then there is a C somewhere, so let's say this is C. Okay, so and then we want to find how many different parallelograms we actually can have with this condition. So let's connect these. So one thing we can do, like we can make I don't know, like we can make a rectangle and then see if we can find the area around this parallelogram and then subtract from the rectangle to get the area of this region, which is possible. But I kind of don't want to do that because whenever you deal with some coordinates, and then if you're asked to find the area, that is usually something we would like to do with the shoelace. So which is why I want to do that. But we don't really have much information other than the area. So and then this is on the y equals x line. So I'm going to call this is going to be x comma y. But the y has to be same as x value, so it should be x comma x. I'm going to call this actually x1 and x1 because the y value will be same as x coordinates. And then this guy, I'm going to call this is like x2, and then k times x2 as the y coordinate. And then we don't know about this one, right? But the thing is, since we are told this is going to be a parallelogram, right? So this guy is parallel to this one, and then this is the parallel to this one. So I know all the three vertices except C, but at the same time, when you take the kind of the midpoint of the diagonal AC and diagonal BD, this guy will be just midpoint of BD as well as midpoint of AC, which means we can use that to get the coordinates of C. So when you add the x coordinates of this one with this guy, so you got x1 plus x2, but x coordinate is 0, so which means this will be x1 plus x2 would be x coordinate. And then y coordinate is x1, and then y coordinate is k, x1, and then y coordinate is k times x2. So I'm going to say this is going to be x1 plus k x2. Okay, so we got these. Now we can write the coordinates in order I like to, and then just use shoelace. So there are two different ways people usually use, but what I'm going to use is just start with the origin, because we're going to write this at the end one more time. And then we can either go this way around, and then or we can go this way around, so it doesn't really matter. I'll go with this after, so we get x1, and then since we went to counterclockwise, I should go with C after. So you got x1 plus x2, and then x1 plus kx2. And then the next coordinate is D, so that should be x2, and then kx2. And then we start with 0, 0, so we are writing this again. And then this is one way of doing the shoelace approach. So we are going to multiply these numbers. So that is just 0. And then we are going to multiply these. So you got x1 times x1 plus kx2. And then we are going to multiply these. So you get k x2 times x1 plus x2. And then we multiply these two, so you got 0 as well. Okay, so similar to that way, so we're going to multiply these, we multiply these, multiply these, and multiply these. So the first one is 0, and the second one is x1 times x1 plus x2, so that one. And then this guy will be x2 times x1 plus kx2. And then this one is 0. So since this looks like a shoelace, that's what we call a shoelace approach. And then what we are going to do, we're going to add these numbers, and then we're going to add these numbers, and then we got the common, like absolute difference between those two to get the area. So that's going to be 1/2 is going to be in the formula, and then we just take the absolute difference of the sum of these and sum of these. I'm going to say when you add these two, so you got x1 squared, and then x1, x2, and then when you expand those, you got x1, x2 plus k times x2 squared. And then since we take these positives, so I'll take the negative version of this. So I'll just subtract these. x1 times x1 will be x1 squared, and then x1 times kx2 is kx1 x2, and then plus kx2 times x1, so kx1 x2, and then kx2 squared. And then we take the absolute difference, and this must be our area, which is given just this huge number. So I'm going to write as 10 to the 6th power. Okay, and then let's simplify this a bit. So you got x1 squared, but there's also x1 squared here, so this one and this one will cancel. And then you got x1, x2, x1, x2, that's 2 copies x1, x2. So let's write down. So 2x1 x2. But we have k x1, x2, k x1, x2, and then there's a negative in front. So you got 2 times k x1, x2. And now we do have the kx2 squared, but this is also kx2 squared. Since this minus will cancel those, these guys will be gone. And we take the absolute difference of this and multiply by 1/2. So, and then this is going to be 2 to the 6th power, 5 to the 6th power. So if I take the 2's out of the way, so you will get product of the x1, x2, and there's also k right here. But since we know that the inside has to be positive because we are going to take the absolute value, so which is why I will just write this as like x1 times x2 in parentheses 1 minus k, but 1 minus k, I don't want to get it negative, so I'm going to get k minus 1 instead. So that means that will give us 2 to the 6th power times 5 to the 6th is equal to x1 times x2 times k minus 1. I hope that makes sense because we want this all these three products to be positive because we are talking about the area, and then x1, x2 is positive. So for 1 minus k to be positive, which like it's negative, but which means we should take this guy minus this one because we are looking for the absolute difference. So that is what we have. So we did everything almost there, but here's the question we should really have. So what? Like we got x1, x2, and k minus 1, right? These are the three positive numbers that we multiply to get this number. But at the same time, how do you deal with that? Like x1 could be, some of the 2's could be x1, some of the 2's will be x2, some of the 2's will be k minus 1. So you just basically distribute the 6 2's between those three, I guess, number, and then the same with the 5. So we have 6 5's. So maybe some of them will be in x1, some of them will be x2, and some of them will be in k minus 1. So basically, your question is now asking to find the number of ways to distribute 6 2's between three variable. So I will say, if there's a question, let's say x plus y plus z, and if this is equal to 6, how many ways can you actually do that? Which is the x, y, z is positive integer. So you can just say maybe 5, 1, 0, but 0 doesn't work. So you just want to say like 1, 1, 4, and some different ways like that. Because if you choose 0 for any of these, then that doesn't work because we want to get x1, x2's are bigger, or at least 1. Because x1, x2 has to be on the first quadrant, and then this is 0, so that means this has to be at least 1. So which means 2 to the 0th power doesn't work. So which is why 2 to the first power, second power, all the way to 6th power. So we have 6 power of 2, 6 power of 5. And then we are also told k is bigger than 1, so which means k minus 1 should be at least 1. So which means 5 to the 0 doesn't work. So 5 to this first power is the smallest number we can distribute for k minus 1 as well. So the question is now, how many ways can we distribute the x, y, z's, like 6 in between x, y, z's? X, y, z represent like x1, x2, and k minus 1. So then you just say, this is just the star bars approach, right? So x, y, z should be at least 1. So we can consider as like, we have 6 stars and then three bars. But so in that case, we do have in total like 6 plus 3 items, but we just subtract 1 because we do have only 2 bars, not 3 bars, to make 3 groups. And then that is 2 bars, and then we just need to choose 2 places to place those, which is going to be 3 minus 1. Again, if you feel like the starting bars approach is kind of challenging at this point, so then it's good to review that as well. So that will be 9 minus 1, which is 8. Choose 2, and that is 28. So there are 28 ways to distribute the 6 2's between these three, I guess, like numbers, x1, x2, and k minus 1. And then the same idea with the 6 5's. So we got 28 ways to deal with as well. So 28 times 20 is actually what we really want to. So which is going to be 784. So I hope that makes sense. The overall idea is we just start with the labeling the points, and then we got the coordinates of the all 4 vertices, and then I use the shoelace to get the area. But as soon as we simplify, we end up getting this expression. So the question becomes, how many ways can we distribute 6 2's and 6 5's between 3 things? And that is just the start in bars ways. So that is going to be 784. So I hope that was clear. I'll see you in the next video.